Two of these, importantly, on the fifth grade tasks have video cases attached to them. So this Candies one, for example, I'll take you through and just look at the task. Now, Candies is asking for, it's a task that I'm sure you've probably seen before. All right, you have a candy factory, and your job is to create boxes for the candies. So, but what it's really getting at is working with these fractions and ratios. So if you take, this is Amy's box of candies, she's already eaten 6 of them. What fraction of the candies has Amy eaten? Now, in some classrooms this might be, okay, she's eaten 2/3, done. Kids are successful, we can move on. But really, we need to understand, what do these columns represent? What do the rows represent? How do those link to the representation of this quantity and this part to whole relationship? Secondly, we can see Valerie shares some of the 12 candies from this box. She gives Cindy 1 candy for every 3 candies she eats herself. How many candies does she give to Cindy? And importantly, show how you figured this out. Right? Those kinds of questions, those kinds of prompts are where we as teachers are going to learn about how are our kids even approaching this. In a packet of mixed candies, there are 2 fruit centers for every 3 caramel centers. There are 30 candies in the packet. So how does a kid even set this task up? All right, 2 fruit centers for every 3 caramel centers, and there's 30 in all. So you can see that this is actually leading towards algebraic representation. But they're trying to get this part to whole and relationship to each other and total quantity and partial quantity all figured out together. And then we actually get Anthony makes candies. First, he mixes 1 cup of cream with 2 cups of chocolate. In all, he uses 9 cups of these 2 ingredients. How many cups of chocolate does he use in the candy recipe? And explain how you figured this out. So this is the first task that kids do. And actually, if you are to look at this video, you can see that this is what Hillary Lewis-Wolfson and her colleagues call a re-engagement lesson. So she's given them this task, and then she has taken the set of student work home with her and looked with her colleagues to say, how did they approach this? How did they set up this 1 cup of cream to 2 cups of chocolate and 9 cups of the 2 ingredients in all? How did they set that up? What does that mean about the strategies that are lurking underneath the surface of their responses to this worksheet? So just to give you that reminder, Hillary's work is investigating students' responses to these and then having the students themselves reflect on how effective are those strategies for solving this problem. So if we go back here and we're going through the task, we already looked at the task, we can look at this rubric. And again, these are all PDFs, so you can print these out for your use at your school setting. But the rubric is going to say, all right, how do you even go about assessing this task? So, all right, they give the correct answer. Is it 2/3 or 6/9? All right. Did they give the correct answer as 3? How did they show their work? This guides teachers to accept these diagrams that they might have used. How do they give that correct explanation? So, for example, Anthony mixes a ratio of 1 cup of cream to 2 cups of chocolate. The ratio stays the same for different amounts. So I wrote the numbers in a chart like this, and so on. This is again that rubric that you can use. But then there's these, what are the core mathematics ideas and challenges in here? So if they're working with fractions and ratios to reason about these candies in a box, they need to find those equivalent ratios. In order to do that, this connects to 2 of those core ideas. Number properties, where they are understanding numbers, ways of representing numbers, relationships among numbers and number systems, and number operations, where they are reasoning about and solving problem situations that involve more than one operation and multi-step problems, and so on. So this is also broken up then. What's the mathematics of this task? Based on teacher observation, what do 5th graders know? What are they able to do? What are these areas of difficulty for 5th graders? All right, so that I can get a sense of how do I anticipate the problems or the challenges that they are likely to encounter with this. There are then these questions for teacher reflection. So if you're a teacher by yourself and you're building your own understanding of this, or how to look at sets of student work, or if you're a math coach and you want to convene a group of experienced or novice teachers around building their capacity to teach this concept, this is a resource you could use. Work that task, look at the rubric. What strategies might kids use to help them solve this task? What are those big mathematical ideas? And then this guides teachers in going through the task and the sets of student work to say, how did they approach this? So there are then these examples of successful student work. Now, these are scans of actual students' work. So this file itself will take a little bit longer to download. You can see down here, it will download more or less rapidly depending on your internet connection. But here's successful strategies. Student A uses 3 different models to think about the ratios. This commentary up here is developed by these mathematics coaches and leaders and teachers to help you see what are these patterns in the successful strategies. In general, these successful strategies are smaller in number than the misconceptions, but you can look at all of these at your leisure and figure out what do you see in these pieces of student work and how do they connect to things that you might have seen with your own students. These misconceptions are, again, a more in-depth tour of what happens when kids have difficulty understanding this. So, in one case, students had difficulty understanding what to do with the scale factor. Student F, whose work is here, is able to think about part to whole relationship in 2 and 3. And this student solves part 2 by counting the number of groups of 4, which is the same as the number of candies. And then the student counts how many groups of 6 there are in 30. Why does this strategy no longer work? What is different mathematically in part 3? Right? So these prompts help you think about what's underneath these wrong answers. Why are wrong answers not the end, but the beginning of some of this teaching into the concept? So again, here's student G, who has a different challenge, and so on. Student H. What you'll see actually in some of these video examples is that teachers are able to use these misconceptions documents with their own students so that they can say, all right, let's give this task, let's try it for ourselves, and then let's say, how did student H approach this? What were they thinking? Where did she or he go wrong? What would you recommend to this student to figure out a better strategy or to understand their misconception? Then we have this graph and analysis of the Mars task data. This will give you a sense of how do students generally experience this particular task, and that you could then apply this to an analysis of your own students' work. The summary of student understandings and misunderstandings. So where did they do well? Where did they have trouble? So for example, students had trouble finding the amount of chocolate needed for a recipe. 8.5% of the students multiplied 2 times 9 to get 18. So they might have read the problem incorrectly. It says something along the lines of, they use 9 cups of the 2 ingredients. Now, some students might read that and say, all right, they use 9 cups of chocolate and 9 cups of cream. But then that doesn't actually pertain to that ratio if it's 1 cup of chocolate and 2 cups of cream. That ratio breaks down if you have 9 cups of each. That doesn't work if you're following that recipe. 5% confused scale factor 3 with the amount of chocolate needed. Other common answers were 4, 9, 2, and 5. So this doesn't have to be a mystery to us as a teacher. We don't have to stop with, this kid just got the wrong answer, mark it wrong, go on with my grading, and so on. But that you can say, well, how does that wrong answer map onto these understandings and misunderstandings, and what does it tell me about how this student approached the problem? Because that's how you're going to get them to be more successful independently.